TOI 700e is one of the most Earth-like exoplanets ever discovered, which means it's a prime candidate for studying the potential for life beyond our solar system. To give you a bit more background, the Transiting Exoplanet Survey Satellite, or TESS, was launched by NASA in 2018, with the goal of searching for exoplanets around near stars. TESS uses a transit method to detect exoplanets, which involves measuring the dip in a star's brightness as a planet passes in front of it. In the case of TOI 700e, it's located about 100 light-years away from Earth, in the constellation Dorado, and it orbits a red dwarf star called TOI 700. The planet is about 20% closer to its star than Earth is to Sun, which means it completes a full orbit in just 37 Earth days. As for the planet itself, scientists think that TOI 700e is probably a rocky planet like Earth, but they're not sure yet whether it has an atmosphere. If it does have an atmosphere, it could potentially trap heat and make the planet's surface habitable. Did you know that TOI 700e is only one of 4 planets discovered by NASA? Interested in learning about the other 3? Then keep watching. The TOI 700 system has been of great interest to astronomers since the discovery of its 3 previously known exoplanets, TOI 700b, C, and D. All 3 of these planets were discovered within a few months of each other by the TESS mission in 2019. Planet D, which is slightly larger than Earth, was particularly exciting as it was located in the habitable zone, which is the region around a star where the conditions are just right for liquid water to exist on a planet's surface. The discovery of a potentially habitable exoplanet was a major breakthrough for exoplanet research, and the excitement only grew when scientists discovered TOI 700e a year later. It took an additional year of observations by TESS to confirm the existence of TOI 700e. This was due to the fact that the planet is much smaller and therefore more difficult to detect than its neighboring exoplanets. However, the extra year of data provided the evidence that scientists needed to confirm the existence of this Earth-sized exoplanet, located within the habitable zone of the TOI 700 system. This discovery is particularly significant because it adds to the growing list of potentially habitable exoplanets that could be further studied for signs of life beyond our planet. Scientists can now use the data gathered by TESS and other instruments to learn more about the atmosphere and surface conditions of TOI 700e, in the hopes of determining whether it might be able to support life as we know it. Emily Gilbert, a postdoctoral fellow at NASA's Jet Propulsion Laboratory in Southern California, led the work and said, "The TOI 700 system is exciting because it's one of the few we know with multiple small planets in the habitable zone. This makes it a good candidate for further study. Planet E is a bit smaller than Planet D, and its discovery shows how TESS observations can help us find smaller and smaller planets." The 241st meeting of the American Astronomical Association was a major event for the astronomy community, and many exciting discoveries were presented during the conference. Emily Gilbert, a postdoctoral fellow at NASA's Jet Propulsion Laboratory, was one of the presenters at the conference, where she shared the findings of her team regarding the discovery of TOI 700e, a potentially habitable exoplanet. The research paper about TOI 700e was later published in the Astrophysical Journal Letters, a respected scientific journal in the field of astrophysics. The publication of the research paper is a significant achievement for the team, as it provides an opportunity for other scientists to review and build upon their findings. The discovery of TOI 700e and its subsequent publication in a scientific journal are important steps forward in the search for potentially habitable exoplanets. By sharing their findings with the scientific community, the team at NASA's Jet Propulsion Laboratory has opened the door for further research and collaboration on this exciting discovery. But you may be wondering, what is the point of all of this? Why should we be scoping out habitable planets? We have the answer to that coming up. If you're enjoying this video, be sure to leave a like and of course subscribe to our channel so you don't miss out on any more awesome content like this. Let's get back to the video. Is our time on planet Earth coming to an end? Will we be forced to inhabit one of these newfound planets in the future? Well, relax, we have good news. New studies showed that it won't happen within our lifetime, so you can take a deep breath. This isn't to say we shouldn't be mindful of our choices and the impact they have on our environment. Humans are causing the Earth to warm up by releasing heat-trapping gases such as carbon dioxide. But there's a more gradual and dangerous warming process happening too. The sun is gradually getting hotter and brighter, which is causing more water to evaporate from the Earth's surface and enter the atmosphere. The additional water in the atmosphere is trapping even more heat, creating a water-driven greenhouse effect that will continue to warm the planet for a long time, even after people stop burning fossil fuels. Eventually, this greenhouse effect will spiral out of control and cause all of the water on Earth to evaporate, which would end life on our planet. In terms of Earth's remaining time, climate experts have conflicting views. In a recent study led by Ravi Kopparapu of Pennsylvania State University, the team used computer models to predict how Earth would react to increasing solar radiation. The researchers found that with just 6% more sunlight, the greenhouse effect would accelerate and eventually vaporize Earth's water. At the current rate of solar brightening, which increases by just over 1% every 100 million years, this catastrophic event could happen in 600 to 700 million years. The process leading up to it would also have some adverse effects. In just 150 million years, the stratosphere would warm up enough to allow water vapor to reach high altitudes, where solar radiation would break it down into molecules that can escape to space. The planet would then enter a moist greenhouse state that would be too hot for complex surface life, but some hardy marine organisms and microbes could persist. However, not all agree with this. Eric Wolf, a doctoral student at the University of Colorado in Boulder, disagrees with Ravi Kopparapu's model. Wolf argues that Kopparapu's model is limited because it only examines one dimension, altitude, disregarding important factors such as clouds and regional differences in humidity. To address these limitations, Wolf and his colleague Owen Brian Toon used a more comprehensive 3D climate model from the National Center for Atmospheric Research. This model included clouds and regional differences in moisture, as well as assumed that atmospheric CO2 levels would remain at 500 parts per million, which is 25% higher than current levels. Last month, a study published in the journal Nature used a 3D climate model and found that a runaway greenhouse effect would not occur for at least 1 billion years. The lead researcher, Jeremy LeConte, who is now at the University of Toronto, says that the difference in results between his study and Wolf and Toon's study is partly due to variations in how clouds were modeled. Planetary scientist James Casting from Penn State University Park, who wasn't involved in the studies, believes that the 3D models provide new insight into the potential lifespan of life on Earth. However, he suggests that the studies may underestimate how long Earth could support life. The models assume that CO2 levels remain the same, but they may decrease as the planet warms. This is due to the acceleration of natural carbon sequestering processes, such as calcium carbonate rock formation, which can remove CO2 from the atmosphere and temporarily slow warming. Casting also notes that the studies do not account for how life will respond, making it difficult to assess how long life will actually survive. Casting suggests that the 3D models can help improve estimates of the habitable zones of Sun-like stars, which are the distances from the star at which planets can have liquid water. Previous research, such as Kopparapu's 1D study, estimated that the habitable zone in our solar system starts just inside Earth's orbit. The new 3D studies, however, suggest that Earth-like planets orbiting Sun-like stars may have a bit more space, with the habitable zone starting at slightly closer distances from the star. This discovery could mean that our galaxy has more habitable planets than previously thought. These recent 3D climate modeling studies provide new insights into the potential longevity of planet Earth, suggesting that it could support life for at least another 1.5 billion years before a runaway greenhouse effect occurs, making the planet uninhabitable. These studies also refine our understanding of habitable zones around Sun-like stars, suggesting that planets like Earth may have a bit more breathing room than previously thought. While these findings are promising, they're not without limitations. The studies assume that CO2 levels will remain constant, which may not be the case as Earth warms, and they do not model life's response to changing environmental conditions. However, they do provide important information for astronomers and astrobiologists seeking to understand the potential habitability of planets outside our solar system, just like TOI 700e. Further study of planets like TOI 700e will help scientists better understand the range of conditions under which life can thrive, and inform our ongoing search for habitable worlds beyond our own. So, will we move to TOI 700e once the Earth ceases to exist? At this point, it's difficult to say whether humans could live on TOI 700e, because there is still so much that we don't know about the planet. One thing is for certain: with the knowledge that habitable planets do exist, there's a possibility that we may even discover more as the technology advances. Maybe we'll even discover extraterrestrial life. Only time will tell.